Hello, everybody. A warm welcome from Berlin, as usual. Today, I'm again with Zane, my best friend, and he absolutely wants to say hello to everybody.
Hi, everyone.
Thank you, Zane. That was fantastic. Today, we're going to talk about installing the Linux version of AIOps, and that in under 2 hours. And for this purpose, we have a community blog. This video is going to talk you through this blog. So what are the single steps that you need to do? And rounding it all up, we have the link into the documentation so you can read it yourself. All that is there. And without further ado, here's the community blog that we're going to use. So short link, obviously under Zane's flag, of course. And I think with that, we are ready to rumble. Over to you, Zane.
Okay, hi, everyone. Thanks, Fred. Thanks, Fred, for the introduction. Yeah, so this is a blog we're doing today called Install Linux-based AIOps in under 2 hours. So in our last blog or video, we talked about how we can install Netcool Omnibus and Netcool Impact in under an hour. Right, so let's say the scenario is we want to set up a system, we want to maybe evaluate AIOps or Netcool or Omnibus or Impact, or we want to do a POC. In any case, we want to get off to a fast start. In that last blog video, we installed the Netcool part in under an hour. In this one, we're going to install AIOps, the AIOps part, and we want to do it quickly because we want to spend, maybe we haven't got much time to do this proof of concept or evaluation, and we just want to give it a try and see how it looks, right? Just in reference to the documentation, all of the steps to do the installation are actually here in the documentation, and it's actually very good. The reason I have sort of made this blog is that there's a few other steps which are assumed but not necessarily fully documented. For example, preparing your virtual machines and copying around SSH keys and so on. They're things that you will need to do as part of your setup, but aren't necessarily called out in the documentation because the documentation is covering just the AIOps piece, not the setup of the VMs. So what I wanted to do was to pull all of the bits of information together to make it as quick and easy as possible to set up your system and get running quickly. So let's get to it. Install Linux-based AIOps in under 2 hours. AIOps comes, the Cloud Pak for AIOps, I should say, in two different sort of main platform varieties. You can install it on OpenShift, of course, which is the original installation platform. But recently, IBM released a version that will install on Linux VMs without having to lay down an OpenShift layer. This version is very, very convenient for quick deployments and testing and evaluation POCs and so on and so forth. It's also being made with the purpose of production deployments as well. For example, if you don't have a need for OpenShift, or you don't have expertise within the company, or maybe that's not your strategic direction, then you can install the Linux-based AIOps as an alternative installation option. It's very convenient, and that's what we're going to be covering today, is how to do it, how to use this platform. Yeah.
Do we have feature parity by now?
Almost. So the Linux-based version is just missing a couple of things now, but it won't be long until there is full parity. Yeah, principally it's the log analysis part, and I think it's the Cognos analytics part is not available in the Linux-based one. But it is from 4.7.0. It is upgradable, and you will be able to acquire those capabilities in due course. Okay, so let's go through this. The first thing we need to look at is to provision your environment. As it says here, the Linux-based VM AIOps installer works on 3 different operating system flavors. So it's very convenient. In my particular demo scenario, I have chosen Red Hat Enterprise Linux 9.4, but you could use Ubuntu or an earlier version of Red Hat Enterprise Linux if you like. The minimum hardware requirements are 9 nodes, 3 control plane nodes and 6 worker nodes, a total of 148 CPUs across those nodes, 358 gigs of RAM, 120 gigabytes of disk per node. An important note here, these numbers in the documentation are minimum numbers. That's what it says, minimum. So hence, uplifting these numbers by a factor is recommended to give yourself a little bit of headroom, because on the other hand, maybe you want to deploy the minimum possible. This is the minimum stated requirement. Just personally, I would always prefer to uplift it by a percentage just to be on the safe side, to give myself a bit of headroom. The documentation also calls out that if you're deploying any integrations, such as the Netcool connectors, you want to add on a little bit more hardware to accommodate those integrations. In any case, if you uplift these numbers by a percentage, you're probably going to be fine in that regard. Another thing which is easily missed, which I missed when I was going through this the first time, the Linux-based version of AIOps requires a load balancer, right? Many people have load balancers in their environments already that you can use. However, in many cases, particularly if you're setting up a demo environment or a POC environment, you may not actually have one available. So these instructions actually include the simple steps of spinning up an extra VM to host and run a load balancer. In this case, we're just using HA proxy, which is very simple to install, configure, and run. I've included instructions on how to do that too. And then finally, if you want to deploy any netcool components, also provision a VM to run them on. In the last video we did, we actually covered all of this. There's actually a companion blog to this one, which says how to install netcool Omnibus and netcool Impact in under an hour. If you want to deploy any netcool components, let's say you've got some probes you want to run or an integration with a third-party system, so you need Impact, see that blog for a suitable VM to install those components on. So in this scenario, Barbara, our IT professional, consults the documentation and comes up with the following VM profile for the proposed AIOps deployment on Linux. So this includes a load balancer host to run HA proxy and a VM to run the netcool Omnibus and netcool Impact components as well. So first of all, it's going to be Red Hat Enterprise Linux 9.4. We're going to have one load balancer host with a modest footprint, 4 CPUs, 16 gigs of RAM, 300 gigs of disk. We're then going to have 3 control plane nodes, 16 cores, 32 gigs of RAM, 300 gigs of disk. This is an important additional thing that these control plane nodes need. You need 2 additional disks added to those VMs. So 300 gig system disk plus 2 additional 300 gigabyte disks. The worker node, similar hardware spec, 16 cores, 64 gigs of RAM, 300 gig disk, and this time an additional 1 300 gig disk. So these additional disks are used by AIOps to store all kinds of data, and they get used when the product is installed. But it's important not to miss these additional requirements. And then finally, I'm going to have one netcool host, and it's just following the spec from the other blog, 16 cores, 32 gigs of RAM, 300 gigs of disk. So that's our set of VMs that we're going to need to set this up. And it says here, she opts to increase the number of worker nodes from the minimum of 6 to 8, right? It says 6 nodes, remember. She wants to increase it to 8. This will provide for node failure scenarios and provide additional resources to accommodate upgrades. If you think about upgrading or running software on Kubernetes platforms, very often when you perform an upgrade, it will actually, for different sets of pods that are being run on that cluster, it will provision and spin up the new version of that code before it tears down the old one. Necessarily, you need more hardware than the minimum because it has to sort of spin up the new ones before it can tear down the old ones. If you don't have a little bit extra to accommodate this additional space that's needed for upgrades will not successfully complete. I think Barbara is quite wise to just add a couple of extra nodes to her cluster to give herself a little bit more working space. This little explanation is noted here if you want to remind yourself of why that's important. And then there's a little documentation reference link there to the documentation for what's been stated above. Okay, so the next section is not in the documentation, but I've added it here because it's actually really important to do this before you attempt to install AIOps. First thing is to update the system with yum update, update all the kernel and all the system patches, and then reboot the machine, shut down, minus restart, do it now. And then on the load balancer host, we need to install this package, HA proxy. This is going to be our proxy load balancer that we're going to use in this deployment. And then on the control plane and worker nodes, we also need this package here, LVM2. Various binaries that come with this package are used during the provisioning process. And if you don't have those, if you don't have this package installed, then the installation will fail. So just make sure you run these steps and you can just run them as the root user on the relevant hosts that are listed here. So all of the hosts need an update. The load balancer needs HA proxy and the control plane and worker nodes need LVM2 package. Okay, the next thing is considering the control plane nodes and the worker nodes. Now, if you recall, the control plane nodes have 2 additional disks added to them, to the VMs, and the worker nodes have 1 additional disk. So these need to be prepared and used before attempting the installation. This particular link here is referenced. This is actually very clear and simple set of steps to run through and mount those drives, format the drives, and prepare them for use by the operating system. So just follow those steps, use the defaults, and then your VMs will be ready to start setting things up. The next section is about updating your local host file. So very often, not always, but very often, demos and POCs are done in an environment that is sort of like a lab type environment, or where the VMs have just been provisioned and are being used sort of for a demo or an evaluation scenario. And those hosts may not necessarily be registered in any local DNS service, right? To ensure that the VMs can all sort of talk to each other and smoothly, it's useful to add local host file entries for all of the machines that are participating in the cluster to each one's etc host file. You know, I've got my example IP addresses here, but basically I've got the load balancer, and then I've got the 3 control plane nodes, and then the 8 worker nodes. Create an equivalent entry, host file entry, and put that in each of your load balancer, control plane, and worker node VM's host files. And that way, all of them will be able to talk to each other based on their fully qualified domain names. The next step is it talks about setting up SSH keys. So again, these are steps that are not specifically called out in the documentation, but are essential for it all to work properly. And that's basically creating an SSH key from the primary control plane. So this command gets you to feed into your .ssh directory and create a new SSH key if you don't already have one. The file we're looking for is this one here, id_rsa.pub. And what you need to do is you need to copy the contents of this file to a clipboard, because we're going to copy this key across all of the other nodes. That's what this next step involves. So we take this key that we've just generated, and we're going to copy it to each of the other nodes, the load balancer one, the other 2 control plane nodes, and all the worker nodes. So basically involves connecting to that target machine and editing the .ssh authorized keys file, and then saving that. Another step which it mentions here is the following is an example first connection where the user is prompted to add the target host to a list of known hosts. So this is an SSH security thing. The first time you connect to a box, it says the authenticity of host AIOps control 1 can't be established, and it actually says this is the key fingerprint. And if it is a demo environment and it's like a newly provisioned VM, it's probably going to give you a message like this. You actually have to type the word yes, and what it will do is it will add that host to the list of known hosts. And you have to do this at least once across all of the boxes to make sure that you've authorized the acceptance of its key when you make that SSH connection. If you don't do that, the installation will fail. So make sure you copy the key, make sure you answer yes to, you test out basically all the connections. If you've done all of this correctly, you copy the SSH key to the authorized keys file on each one. You should be able to SSH to your primary control plane node, and from your control plane node, you should be able to SSH to all of your other nodes as well. And with the SSH key in place, it will not ask you for a password, and it won't ask you, do you want to continue connecting? When you get to that point, you're ready to do the install, and it will be seamless. Okay, this next step, now that you've set up all of your control plane nodes, your load balancer, and your worker nodes with the key generated on the primary control plane node, now you're going to set up an SSH key on your deployment machine. So this might be my laptop, right? Because I'm actually going to initiate the deployment from my laptop to the control plane node, and then the control plane node is going to then execute all the commands and all the others. Everything's going through the primary control plane node. If you look at the documentation, it talks about commands in this format: SSH to target user, which is root, at the control plane node, which is the primary control plane node. And then it says issue this command, which is SSH target user at the CP node. So this is going around each of the other control plane nodes. And then finally, it issues the actual command. This little section is actually telling you how to set up an SSH key on your laptop, create one, and then copy that to the authorized key file on the primary control plane node. This will allow you to SSH seamlessly to your primary control plane node without having to enter a password and without having to answer yes, you want to continue connecting. Test it out before you start the installation, and then answer yes when prompted to any questions. Once you've done that, your system is sort of all prepped and ready to go, and your keys are in place, and you've got clean and easy access to all of the machines from your laptop via the primary control plane node. So the next step is setting up the load balancer. So this is another section which isn't included in the documentation, because the assumption is that you already have a load balancer, or that you're going to take the job of setting up your own one. In this scenario, though, we're doing a proof of concept, we're doing an evaluation, we're setting up a test environment. We have provisioned a virtual machine to use for our load balancer, and we just want to set one up and get it going. We don't really too worried about doing it any particular way. We just want to get the load balancer up and running. So we're using the free open source version HA proxy. And as you recall, when we were setting up the machines, we installed the HA proxy package on our load balancer VM. What I've done here is I have provided a full haproxy.configuration file suitable for use for running AIOps on Linux. I've done the hard work for you here by creating you a sample file to use. So in this sample file, you can leave everything as default. You don't need to change anything. The only thing that you would change is the IP addresses called out here. So basically, the backend AIOps backend, it round robins across the control plane nodes. So what you'll do is you'll simply put in the IP addresses of your 3 control plane nodes here, here, and here, right? Then we've got the K3S backend, same again. The IP addresses of your 3 control plane nodes. That's all you need to change. Don't change anything else. Don't change the server name where it says server 0. You only need to change the IP addresses. That's all you need to change, right? And then finally, we've got the backend AIOps backend, and that again, we will simply change the IP addresses to match those of our 3 control plane nodes. Okay, once you've saved that file, these little steps here sort of say cd to etc HA proxy, make a backup copy of the original file, and then put this one in its place. And then using the systemctl command, we're going to enable it, we're going to start it, and we're going to list the status. So a little note here, don't worry if you see some errors in the status output. It will say that because these endpoints that you've specified, they don't exist yet. We haven't installed AIOps. It's not going to be able to connect to anything. That's fine to just ignore that. But the main thing about running the status command is just to make sure HA proxy's up and you can see it running. Okay, so now we're at a point where we've got our load balancer set up and running. We've got all of our VMs updated. All the SSH keys are all shared around. We can connect seamlessly between all of the VMs. We're really ready at this point to install AIOps. Right. At this point, I jump to the online installation, which is linked here, and it's a case of following these installation steps. So if we look here, just going to zoom in a little. Okay, retrieve your entitlement key. This is a case of going to your My IBM Container Software Library, getting your entitlement key, copying it and saving it to a safe place in a text file. You're going to need this. Okay. If you're using a custom certificate, you follow the step here. If you're not, you can skip this step and just use a self-signed one. Configure the deployment type. This will just be a base deployment normally. Extended deployment, there's some additional options there as well. Creating the environment variables. This is basically a template for you to use. What you will do is you'll copy this onto your deployment machine, which is your laptop, and you will update it accordingly. So this bit here, the export accept license, you would set it to --accept license. The IBM entitlement key, this is the one that you will put in that you've copied from the container library, your own entitlement key that entitles you to use the software. These next lines here, the load balancer host, we have set up that load balancer, and we're using the fully qualified domain names in each case, right? And this is why it's important that we added those hosts entries to all of the nodes that we're using. And that includes the laptop that we're deploying from. And when I make reference to these hosts, it needs to be able to resolve those fully qualified domain names to actual IP addresses. So this is where this is important, using fully qualified domain names. You can put IP addresses in here, but either one works. The control plane node, this is the primary control plane node, and then your secondary and tertiary ones are listed here. Again, fully qualified domain name or IP address. Then the next bit is a list of all your worker nodes, 1 per line. So that's the fully qualified domain name or the IP address in each case. And now to know we've got 8, so we just add an extra line to this. And then finally, this is the storage paths for both the application and the platform. This is using the default. If you recall, when we're setting up the disks in one of the previous steps, we would be basically referring to those volumes that we set up in that previous step. So these are the additional hard drives that are being provisioned on those machines. So 2 extra disks on the control plane nodes and 1 extra disk on the worker nodes. I would recommend just using all the default variables, default paths for everything. It just makes it much simpler to replicate. So you've created this file here. The next thing is to run the following command to source your script, right? So from the deployment machine, you're going to run this command and basically just load these environment variables. So now they're all prepped and loaded. You can now run step 5. So this is done by copying this to your clipboard and then running it in your command terminal. So assuming that you've set up all of your environment variables, it will just run through this set of instructions and it will pull the image from github.com, unpack it, and install AIOps which is a utility on the control plane node, the other control plane nodes, and all the worker nodes. So that's what the script is doing. It's setting them all up with AIOps CTL. So it's basically standing up the AIOps CTL cluster ahead of the AIOps installation. Once that is finished running through installing and setting up AIOps CTL, you can then run this command here, AIOps CTL cluster node info, or AIOps cluster status. And it will basically give you an output to show you that all the details of the cluster, the AIOps CTL cluster. If you are running your system on VMware vSphere virtual machines, there's a couple of additional checks to do and a way to sort of circumvent any potential issues. If you're not running it on VMware vSphere virtual machines, you can skip this step. In any case, you could run this command and it says if lookup is successful, then proceed to the next step. The next thing is to install the Cloud Pak for AIOps. So basically that is done. If you did not configure a custom certificate in step 2, then run the following. So chances are you haven't done that. You're just using the default self-signed certificate. You simply copy and paste this command. You notice again it's using our environment variables that we set up earlier. This particular step will take about 45 minutes or so to an hour to actually install and set up AIOps itself. As it goes through, it will basically give you sort of a status update of where it's up to with the deployment and how many packages there are to install. At the very end here, you can run AIOps server status or AIOps CTL status, and you should see something along the following lines. You'll see getting cluster status, control plane nodes, the worker nodes, and then it will basically say all of the AIOps components that are ready. If it says all of this, you should get that message at the bottom saying that AIOps installation is healthy. So at this point, you have successfully deployed AIOps and you can log in. And using these little command here, the server info show secrets, it will print out to the screen the URL that you need to connect to, the username and password, and you can log into AIOps and start using it. Okay, so that's that. So that's basically the installation steps. And you can see why I created this blog, because there's a whole load of other stuff that you have to do before you actually get to that point. Hopefully, this will help somebody get through that a lot more quickly and avoid a lot of the common problems that people run into when they're trying to install this. There's some additional notes here at the bottom. If there is a known issue in the AIOps deployment where it may get stuck on the deployment of the AI Manager component. This is because an internal process is trying to connect to the AIOps console via its fully qualified domain name instead of its internal service name, right? So there is a workaround to this. So if you do see that your installation gets stuck on that, you can simply SSH to your primary control plane node after you've installed AIOps CTL, steps 1 to 4, and then run this following this command here. Okay, this is an example. Obviously, you will put in the IP address of your load balancer here and your load balancer's fully qualified domain name. In my case, I've got mine's called AIOps Linux load balancer.ibm.cloud.private, but yours may be something else, and then it's basically CP console AIOps in front of that. So running this simple command simply adds this line to your core DNS service, and then when you do run AIOps installer, it should complete just fine. There's a little note here to keep a copy of this command here that you make in case you need to add other IP addresses to your core DNS service. Core DNS service is basically a little DNS service that runs within your AIOps CTL cluster, provides DNS services to everything running in there. It's very convenient. If there's any IP addresses or names that you need to resolve, you can just basically add more and more entries. But it is cumulative. Every time you run this command, it replaces what's there, right? So let's say, as in this example, you were adding your netcall connectors later and you needed to add some more entries to your host file, you would just add these additional ones as it's shown here, and then you would rerun the whole thing and it would basically replace the existing setup. So in summary, the new Linux-based deployment for AIOps provides a quick way to get up and running with AIOps within a couple of hours. So this whole process took me about 2 hours to do. Hopefully it will take you something similar if you just carefully follow the steps. After completing everything, AIOps CTL status command should give you this AIOps installation healthy command. And then once again, as we saw in the documentation, just a reminder of that command to get us the login URL and the username and password. And then that's it. You're ready to start working with AIOps. You can log in, start setting up your connectors. If you've installed Netcall Omnibus Impact already onto your VM, you can follow the steps in this blog to get that done if you haven't already. And then you can start to set up the Netcall connectors. If you've set up a SymNet probe, as is suggested in this previous blog on the Netcall VM, you'll be able to start seeing events flowing into AIOps and start setting up some demo scenarios. So back to you, Fred. That's all I have today.
Very good. I love it. Short and crisp. So installing AIOps in something like 2 hours is a great promise, and you have obviously already achieved it.
Yes, that's right. Yeah.
Cool. I love it. Well done, Zane, as usual. Besides this run through of the whole blog, we do have again this link into the documentation. So this is what Zane was showing during his presentation part. There is an extensive part in the documentation about this topic, quite a number of things outlined in here. We've just recently introduced the Linux package, so it's not available in the earlier ones. So I think this is something that came up in 4.7.0. So we've just introduced and released 4.7.1. So if you do not have the trick with the latest up here, so I have printed in here in the link 4.7.1, but if you want to be safe, you can amend your links and use, instead of 4.7.1, the word latest. Then you always have this bookmark opening the latest version instead of the one you just created. So that's a little hint. And I think besides that, we're done. So thank you, everybody. Thank you, Zane, for preparing all the material, writing down the blocks and creating all the material. Thank you, the beloved audience, for taking again some time to listen to our videos. And I'd love to see you in another video when it's about AIOps explained. See you then. Bye.
Thanks, Fred. Bye.